we are looking at well, circular economy, and how can these technologies be used to support the circular economy? Because if you are going to have a circular economy, then you need to also start collaborating between the organizations much more than you do. So in this work package that we have in the project, we have taken flat glass as one kind of the example use case that we're working with. So flat glass that you have in your windows in a building, how can we get that flat glass back so that we can make new windows of it? And we've mapped out this circle basically, and all of these actors in this circle need to communicate with each other, because the manufacturer needs to know exactly what type of glass it is to be able to treat it in the right way and so on. And the recycler, one step before that, needs to know, okay, where how much glass can we get, and from where, from what buildings are being renovated and torn down and so on. So all this sets different requirements on each other, and needs to exchange information basically. And that's where we are doing this modeling to figure out what are the different concepts involved, what are the parameters, for example, like one organization needs the weight of the glass, another one needs the measurements of a window, and another one needs some other kind of data about this glass and so on, the thickness or the material composition and all these kind of things. And we need to be able to cover all these things with these models. While we are still in like the construction industry, and when we've restricted the case to flat glass, for example, then it's we have a head start, because still we are talking, we don't have exactly the same data formats, but we are talking more or less about the same things. So the big challenge arises when you start to doing this on a larger scale and saying, well, all building materials, or even all materials across any domain. We've noted that then even the terminology about products and materials differ between different industry domains. So what some consider a material, to others that's a product, for example. Ontology is a model for defining concepts and relations in some domain, so that we can clearly understand their meaning and share this meaning with others also. The point is that you have to create kind of multiple of these ontologies or multiple descriptions. So I mean, in principle, I could make one ontology for each person or something, but we need to generalize a bit more than that, of course. But let's say for one domain, you can create, this is the ontology of this domain. This is how they define things, how they measure things, and so on. And then you can have another ontology that describes another domain or another industry or another company or whatever, like in this way. What they call X is what they call Y. And then I can say, okay, these maps, there are different terms, but this is the same thing. Or I can say, no, to transform, not explicit, but as soon as you start to define it really, you can also start to make mappings between basically their ontologies. So in that sense, that's how we deal with these differences, rather than trying to fix them, but we have to find the mappings between them basically. It's an important problem, because I mean, of course, you can make technologies that solve, you know, all problems are important, and you can improve someone's daily life. That's fine, but you know, it's like showing that these can have an important impact on something as big as like sustainability and so on, then I think that makes a big difference. And hopefully, I mean, I can also make others more aware that these technologies exist, and that it can be more widely adopted in the future. I think together, I mean, hopefully this can become something that enables some of these collaborations that we need to find in order to actually have a circular economy to some extent.